DC circuits. Let's explore!
Every electrical system has three basic parts, no matter how simple or complex it is. It has a source, a load, and a circuit. The source is a device that develops a voltage. The load is a device that performs a function when current flows through it. The circuit is made up of conductors connecting the source to the load. This is a basic DC circuit in operation, but we're going to need some help turning it on. Gizbot, can you help?
Yes, I am ready.
Okay, Gizzy, let the electrons flow. Good! The circuit is now in operation. The source is the battery providing the voltage we need. The load is the light bulb. The circuit is the wire connecting the source to the load. To help visualize this circuit, let's look at what a practical source might look like. This is a typical battery. It's a 1.5 volt D-cell battery. The load might be a real light bulb, like this one, used in older flashlights. A battery produces a difference of potential, or voltage. This means its positive end has a different number of free electrons than its negative end. This is done through chemical action. DC, when talking about electricity, means direct current. The electrons in the circuit flow in one direction only, positive to negative. Some facts on batteries are: a battery is a good source of voltage. Batteries come in all shapes, sizes, and types. Some are rechargeable, and they are made in all kinds of voltages and current capacities. Let's peek inside a battery and look at a circuit in operation. This next graphic will illustrate electrons flowing inside and outside the battery when it is connected to a load like a resistor. I'd like to first explain why this circuit looks like the current flow is the opposite of the earlier example. In this one, we're seeing the battery circuit at the basic atomic level where the atoms are actually giving up electrons. Electrons are negatively charged, so when a source gives up electrons, it's naturally attracted to the positive end and repelled by the negative end. I know that might sound a little confusing, but Professor JB says, don't worry, you don't need to know that right now. The positive end of the battery and the negative end of the battery. This is called polarity. Current is measured in amps. Small amounts of current are measured in milliamps, or 1/1000th of an amp. Notice the ammeter. It's measuring nearly 10 amps. Each little white index mark is 10 as we count to full scale: 10, 20, 30, 40, and 50 amps. Now look what happens when we increase the resistance. The pinwheel that drives the ammeter is slowing down, and the current is being restricted. At this point, the meter is reading about 1 amp. As the resistance increases, the current decreases. How cool is that? It's time to introduce a very important law. Ohm's Law. We mentioned this in the class on resistors. Simply put, V equals RI. Or here at Jellybean Academy, we have another silly saying, Vermont equals Rhode Island. This helps us remember that voltage, V, equals R times I. Resistance times current. Here's a really helpful way to use Ohm's Law. It's the Ohm's Law Triangle. V for voltage. R for resistance. I for current. If you're wondering why in the world we use I for current, it comes from the Frenchman, Mr. André Ampère, for the French word meaning intensity. So here's our formula. V over RI, or V equals R times I, and R equals V divided by I, and I equals V divided by R. Ohm's law in action. Let's calculate the value of the DC circuit's resistor. Volts. The source in our circuit is supplied by the battery that provides 1.5 or 1.5 volts. Current will be measured in the circuit with our virtual ammeter. Then we will calculate, using Ohm's law, the value of the resistor. An important fact to take note of is if you know any two values, you can easily find the unknown or third value. Okay, Spark Chasers, here's our DC circuit. This is one of the simplest DC circuits that we can make. For demonstration purposes, we have our load, which is our resistor. And what else do we need? We need a source voltage. And that's a single cell battery, much like a flashlight battery, 1.5 volts. So voltage here in this circuit will equal 1.5 or 1.5 volts. Now, to complete this circuit, we have a switch here that has to be closed. Right now it's open, so the electrons cannot flow out of the battery through the load resistor and back to the battery again. So we can close this switch and watch the electrons flow. And let's do that right now, okay? Here we go. Now, the electrons are flowing. We have a completed DC circuit. Electrons are flowing through the resistor, which, what does the resistor do again? Yes, that's right. It restricts current flow. So we will see the current being reduced as it flows through this circuit. All right? I'm going to measure the current with an ammeter that I can plug in line in here. This will be in series. An ammeter will be in series, and it can be placed anywhere in this circuit. And it will measure exactly the same thing, which I can show you here too, no matter where we put it, as long as it's in series with our load and our source voltage. Okay? So the switch is closed, the resistor is resisting, and the voltage is volting. So if I click right here, now, magically, we see that there is 1.5 milliamps. Remember, current is measured in amps. Well, a milliamp is 1,000th of an amp. So we have to move our decimal point over 2 places, or a total of 3, 2 more after here. So it'd be 0.0015 amps. But we're going to settle with our 1.5 milliamps right now. When we go into our formula of Ohm's law, we will be able to calculate the value of this resistor. How big is this resistor? Knowing that we have 1.5 volts and 1.5 milliamps of current, we will be able to determine the value of this resistor. This is fun, kids. So stand by. Here we go. I've asked Professor Jim to draw the Ohm's Law Triangle for me. He's really fast. Thanks, Professor Jim. I'm going to add the symbols for our formula, V, R, and I. Then you will see me substitute them for the actual values. The voltage is 1.5 volts. The resistance is unknown, and the current we just measured is 1.5 milliamps, or 0.0015 amps. Now, let's solve for the value of R. R equals 1.5 divided by 0.0015. Moving the decimal point over 4 places, we get 15,000 divided by 15. So that means R equals 1,000 ohms. See how easy that was? Gizbot wants to review what we have learned. Can you help him? What are the 3 basic parts to every electrical system? What is Ohm's law, and what rule is important to remember? Can you remember the Ohm's Law Triangle? What does Vermont equals Rhode Island mean? If you don't remember, you can go back and review our lesson. Good job, everybody.
Congratulations, Spark Chasers! This is your Professor JB. I'm the Dean of Jellybean Academy, and I would like to thank you for completing your basic DC circuits class. Now that you know about voltage sources like batteries, I hope you will get a charge out of taking more exciting classes. See you again soon.